Chris, and I'm a senior software engineer at Wing Cloud, a small startup that's building developer tools. Before then, I was at AWS, where I worked on AWS CDK, an open source infrastructure as code framework. Before I get started, if you want to reach out to me later, my email and socials are on the slide. But yeah, I'm here to talk about and introduce all of you to Wing, this new cloud-oriented programming language we're building that we're really excited about. So my talk is basically broken into 3 parts. I'll start with some motivation for Wing, giving a little bit of history about the infrastructure as code world. Then I'll dive into Winglang and the ecosystem we're building around it, and do some live coding. Please pray to the demo gods for us. And finally, I'll try to end with some closing thoughts. So let's get started. So yeah, let's start with some motivation. Like, when I change a line of code, the first thing I want as a software engineer is to get feedback on how it changes my application. I think this is like at the core of most engineers' inner loops. Whether I'm prototyping a new feature, validating a fix for a production outage, or just trying to understand a new system that I'm getting familiar with, getting quick feedback on our code changes is like one of the most important parts of being productive on an engineering team. And if validating a change takes hours, then at best, I get to do lightsaber duels with my coworkers. And at worst, my company is probably losing out on customers. And I think this iteration speed is also part of the reason why the journey to going cloud native has been so hard. And to understand a little more why, let's dive into how cloud automation has gotten to where it is today and what's still missing. So I've broken it down into some eras. So in the beginning, there was ClickOps. I'm not sure this actually happened first chronologically, but it's sort of the lowest on the automation hierarchy, so we're sticking with the story. So the IT admin or tech lead, would go to the web console for AWS or Azure or GCP, make a few clicks, and you'll have a cluster up and running, right? Or a database or an S3 bucket or a VPC. And with some set of resources available, you can write your application logic around them and then deploy your code to some choice of compute and live happily ever after. I'm skipping a lot of steps, but this works. And we still do it today a lot, but it is a bit error prone, right? Anytime you need to make changes, you need to go back into the console and make sure that you're creating, updating, or deleting the right resources by hand. So that's not too great. So as a solution, we can welcome bash scripts and Python. Using some code, we can make calls to an SDK, and the script will automate the process of creating a bunch of resources. This also works pretty decently. But it also makes it tricky if the set of resources in your application needs to change often, right? Because you need to make sure you're updating a resource if it's already there, or deleting a resource if it's no longer needed. You also need to implement error handling or retry logic for if and when you get errors from the cloud provider's APIs. So pretty handy for one-off scripts, but maybe not the most robust solution. So to solve these issues, we can welcome CloudFormation and Terraform, some tools introduced in 2011 and 2014, respectively. These are pretty widely used tools that basically let you provision cloud resources for you by letting you declaratively specify which resources you want. So based on what you list in the configuration file, maybe YAML or JSON, the Terraform or CloudFormation or any of these other tools figures out the right set of operations needed to achieve that desired state. So if a resource is missing, it automatically creates it. If it's already there, but it needs to be reconfigured, it updates it, and it figures out that difference in the right operations for you. And so managing cloud resources using these tools has been hugely impactful for both individual developers and for large organizations, because it's a much easier model to reason about. It also makes it easier to see in one place what are all of the resources you're using, which can be useful for tracking ownership or trying to estimate costs. But supposing your application has grown, right? Everyone on your team is afraid to touch the configuration because it's gotten so large, and if it ain't broke, don't fix it. Perhaps there's a lot of configuration repeated, or it's grouped into patterns with all kinds of slight variations. There are some ways to make your code more dry, but because they're configuration languages, it's a little bit more cumbersome if you want to reuse constants or strings or even modeling like basic conditional logic. And so what we've seen kind of over time, at least watching the space, is that a lot of these configuration languages end up looking more and more like ordinary programming languages. And so that kind of brings us to the era of IAC frameworks. So with CDK, for example, you can essentially express, yeah. So with CDK, you can express and model your declarative infrastructure using a familiar programming language, and basically relying on all of the abstractions and capabilities that you can do in Python or JavaScript or Java. And so in practice, the way it works is you write a snippet of code in CDK, and then execute the program, and it will then produce CloudFormation or Terraform that you can deploy. And so you get both of the benefits of declaratively modeling infrastructure and the power of programming languages. And this was pretty popular when I was at Amazon. And I think the reason it was so popular was that there's a very strong DevOps culture there, right? When my team created an application, we were responsible for owning it end to end, both designing it, engineering it, deploying it, and then managing the operations. If there were failures, if I'd get paged in the middle of the night sometimes. And this also meant but the benefit was that using the same programming language for my application code and for my infrastructure reduced our cognitive load as engineers and as a team. All that said, CDK also wasn't all sunshine and rainbows. While it was easier to add new resources, it also exposed some of the challenges that came with applications that lean heavier on the cloud, which we're starting to see more of today. So an obvious issue was developer iteration speed. If you can unit test something by just mocking a few endpoints, then you're in luck. But otherwise, testing an application often meant you actually had to deploy something to the cloud in some kind of staging environment, perhaps, and that took like minutes, to possibly longer. The other thing we noticed is that as we built larger applications, there were all of these cross dependencies between application code and infrastructure code, which were tricky to manage because they lived in separate files and in separate parts of the code base. As Gregor Hope, a senior architect, describes in a blog post that I really love, he says, traditional IAC defines a resource hierarchy. In contrast, modern cloud applications, especially serverless applications, tend to be more fine-grained. And the relationship between components becomes more of a first-class consideration that should be represented in automation code. To rephrase this, or to take a corollary, what we tend to see is as applications use more optimized and purpose-built resources, which is one of the benefits of the cloud, the tighter the infrastructure is tied to that application. So this kind of models some applications. Event routers, orchestration engines. These are, in a sense, application-level components whose configuration depends on both application data and code. And as a result, code deployments and cloud service changes are more likely to happen at the same frequency, right? And they have to be kept in sync. Unfortunately, there just aren't great tools for this today. There aren't good tools that bridge the gap between these two sides today. And so that's why we're building Wing. So Wing is this new programming language designed to make it easier to build scalable and maintainable cloud applications. So when you compile a Wing program, it's designed to produce something that you can run on the cloud instead of something that runs on your machine, on a single machine. The other important facet of Wing is that it makes development iteration really fast. And we do that by simulating a tiny, imperfect version of the cloud on your own computer. Now, words can say a lot, but I think the best way to show it is just to demo. So let's do some coding. OK, so you guys can see. So here I'm in VS Code, which is my personal editor of choice, although we have community members also using Wing in IntelliJ and NeoVim and other editors. And the simplest program you can write is just like creating an S3 bucket, for example. And what we can do is we can run the command wingit to view it in our cloud simulator. So this is just kind of like a simple visualization showing the resources in our application. But the other thing we can do is we can, let's open a separate terminal. We can compile it to some target. So I'm going to say I want to compile, actually, if we look at the options, we will get, we support a bunch of different targets. For example, Terraform with Azure, Terraform with GCP. But if I compile with to AWS, for example, then we'll actually get some Terraform as an output. So here's a Terraform configuration file. And we can see there's actually like an S3 bucket. OK, so nothing too crazy here. Next, let's try adding some piece of compute. So in this case, I'm going to use a serverless function. But we also support like workloads for like long-running services. And what we have is this cloud function expects something we call an in-flight closure, which kind of looks like a regular function closure, maybe from JavaScript, but with this special in-flight keyword. And if you had to kind of distill what makes Wing unique in a single word, it's this keyword. This keyword, in-flight, says that this piece of code, whatever I'm running inside, is going to be run later in the cloud. And so it'll actually get bundled into some kind of container image or, say, zip file with code. So let's do something simple and say, hello, Civo 2024. And then I can switch to the Wing console. Everything kind of updates instantaneously. And I can click on this function, invoke it, and we get the log. So it's working. So that's just in our local simulator. What happens if we tried deploying this to the cloud? Well, we can compile it again. And we can see the compiler actually does all of this heavy lifting for that you might ordinarily have to manage in your configuration. For example, we're creating IAM roles, we're creating policies, a Lambda function, a bucket for holding the code, and so on and so forth. But now, you want to get some work done. You want to actually try interacting with these resources. And so I'm going to assign this bucket to a variable. And then we can try, if I start typing like b dot, I'll see the list of methods available on this cloud bucket. And we can see kind of what we might expect if we were operating, with, say, the AWS SDK, perhaps. These are common operations available on storage buckets for the major cloud providers. I kind of think of them as like data plane operations, so putting objects, deleting, listing, and so on. But the interesting thing to note here is these operations are available in part because we're in flight. Whereas if I instead decide to see what things I can do here outside of the in-flight keyword, I actually get a different set of methods available. And this is because the default mode of each Wing program is basically the infrastructure. It's when we call it pre-flight. And so all of these methods are actually going to make changes in the infrastructure as code world, or to the infrastructure plane. So for example, I can add a file at deployment time, or I can set up some kind of notification handler that automatically runs code every time an object is uploaded. And this will end up creating some new Terraform for us. So let's keep this simple and just say we're going to put some object into the bucket. And then I'll hit save. We can move to the simulator. I'm going to invoke the function, and then if I click on the bucket, I can actually see all the files that are inside. If we scroll, and we see the file is there. And believe it or not, we're actually modeling this S3 bucket, just using your local file system on your machine. One other thing that's kind of interesting that I'd like to highlight is, this graph of resources that you see here. It's actually showing this relationship between the function and the bucket. And this is something that you just can't do in infrastructure as code tools today, because currently your Terraform or CloudFormation, it treats whatever is running in your container as a black box. And it's only because we're designing this language that kind of has visibility over both sides that we can kind of analyze these relationships. What that also means is if we try compiling this into some Terraform that we could deploy to AWS, it's going to automatically generate least privileged permissions, which hopefully the security people love. Because we all want kind of minimally scoped permissions and such. And so if we try to find the policy, by the way, yeah, this is JSON, which is a supported form of Terraform, but we're working on getting HCL output working as well. Right, and if you look here, we can see that the put operation permission has automatically been generated by the compiler by statically analyzing the code, which I think is really cool. OK, so those are some of the basics of Wing. You have pre-flight, you have in-flight, but what can you build with it? Right? So maybe we'll try, for sake of demo, building, it's a little cliche, but we're going to try building a URL shortener. Because it'll show how we can kind of create some API endpoints and how all these different pieces of the language work together. So to get started, yeah, we're going to create an API. So this is going to let us essentially create some routes with different handlers associated. And maybe we have a shorten endpoint. And let's just start with something basic, just to see that the endpoint is working. So shorten called. Then if we move here, you can see it's updated. We actually have a UI that kind of lets you easily test these endpoints. You can see the log worked. By default, it's just returning a 200 response because we didn't specify anything else. So now, like, perhaps, yeah, how are we building this URL shortener? Let's try to keep going with the bucket example. Just storing the data inside of a bucket. Like, we're going to have like a lookup between IDs and the URLs. So I'm going to create a new bucket. Next, let's, we want to generate some kind of ID. Maybe we'll do that by, creating a random number. So let's bring the math module. I'm just going to create like a random kind of 3-digit number. How is the URL passed? Maybe it could be through the body. Maybe I'll start with just like a URL, like a query parameter. It's kind of a convenient way. So this method can accept a request. If we mouse over, we get all these built-in auto-completion documentation. We want Wing to work well in all kinds of IDEs, so we're using this thing called the language server protocol, which means it's very easy to add support for new IDEs, and you get like a great editing experience with great error messages. And what I guess a consequence of that, going off on this tangent, is like when you compile a Wing program, if it works on your machine, it's going to work on the cloud. That's the guarantee we want you to have as a developer. So let's get the URL, and we'll say, there's this query field, and I'll just extract the URL. We get some kind of string. And then inside here, let's see, we're going to get rid of that. Let's say data. We're going to store the ID as the key, and then the URL string inside. We actually also have like a Redis module you can use, but I don't want to get into that quite yet. So, okay, so let's test this out. Let's just go here. Maybe I want to put, this parameter of the Wing website, winglang.io. If I hit send, I got a successful response, and I actually kind of see this thing is in the bucket. Oh, this is still left over. I'm just going to delete it. Cool. Okay. And maybe we actually want to return the full URL that you're going to access. So let's say we return a 200 response, and let's see. Well, it's going to be at this endpoint of the URL, so we can access basically some piece of infrastructure, like an attribute of the infrastructure, which is going to be this API endpoint that's generated for us, and just kind of reference it in flight seamlessly because we have this relationship. We don't have to pass an environment variable and kind of glue things together. And maybe it's just going to be, the convention is just going to be to access the endpoint at this ID. So now let's just flesh out this example. So we're going to have like a get operation. So you pass some kind of ID. Actually, we're going to use the request. And then, let's see. Let's get the ID from this request. There's a variables field. And we can just get ID. Then what do we do? Let's say we're going to look up in the bucket to see if we already had a URL with that ID, because if someone just made up an ID, of course, there's going to be some kind of error. So let's say so data to get. Actually, we can call try get, and this will kind of give us like an optional value back, so a string or nil. So let's look up the ID. We'll say if let URL equals URL. And then if this is the case, what would we want to happen? We probably want to like redirect the user to that to the website that they've shortened. So let's return like a 302 response. And the URL will just be that URL. Otherwise, maybe we return like a 404 status and say URL not found. Okay. Okay, we're getting a compile error. Okay, semicolon. Cool. So now let's try shortening this again. So we get an endpoint. This is because we're simulating on our own machine, we get something on our local host. Moment of truth, let's try visiting it. And it takes us to the Winglang. Woo! So yeah, that's a very basic example. The other part of Wing that's like so useful is because we have access to the infrastructure and the application code, you can kind of start designing abstractions and say classes that kind of encapsulate different aspects of your backend system or common components that you're reusing in a way that you might not necessarily be able to do if you're just using Terraform or CloudFormation or other tools like that. So for example, I'll just call this a URL shortener. And I can just basically grab all of this and move it into my constructor. And then maybe I'll have like some resources you can kind of give these names. So maybe this one is going to be like an internal shortener, and this other one it's going to be a public one. And we can see it's like already getting visualized in the console. We can kind of debug each one separately. And I think this is like there's a lot of fun things you can build. Like for example, the other day, I wanted to cache the results of my Lambda function. And this is something that AWS actually provides through, I think, this like extension library called Power Tools. But you can also do this very simply through a class. So for example, we can create like a cacheable function. And then this, let's try this out. We can create a new function. And maybe we're going to give it our own in-flight API that lets us like invoke it. So let's give it like a field. This.f. All right, we expect some kind of code. So we have first order. Functions are first class citizens in this language, so you can kind of pass higher order functions. So we can just pass that. The function will take some kind of payload. And so this is just going to, so right now we're just kind of like wrapping over the built-in cloud function, but perhaps we want to like, it's doing some kind of expensive computation. Maybe it takes several minutes. Then let's create, actually let's try the Redis thing, even though I haven't practiced this part. So let's say cache is, it's, yeah, we have something built in this like extensions module. So this dot cache equals new Redis. And let's see what methods are available. So we're going to, let's see. This cache. OK, we have a set, get. Let's try this. So set expects a key and a value. OK, so maybe first we're going to try get, and we're just going to require this payload. So this is going to be the existing value. If it's already there, it might fail. Like there might not be something cached. So in that case, we can use this like if let expression. So if let value gives an existing value, then we're just going to return that. Yeah, maybe that's fine. And then otherwise, we're going to actually compute the result. So we can say this.f.invoke with the payload. And by default, it expects like an optional string for some kind of technical reasons, but we're just going to unwrap that. And then let's update the cache. This.cache.set. Yeah, so we'll set the value. And return the computed value. Now, how do we test this out? Another great thing we can do in Wing is like you can write unit tests. So like we believe a lot in like test-driven development. And it's just like it's also super cool because you can run the tests locally against the cloud simulator, and then you can also run the tests, for example, in your CI/CD against the cloud environment, just to like sanity check that. Maybe you're integrating with some existing data source, like that will continue working. So let's create a cacheable function. And we're expecting this thing. What do we want to do? Maybe we're going to like parse this. We're going to have some kind of number. We're going to like parse the string as a number, and then just double it, and then kind of turn it back into a string just to make the code happy. Yeah, that's fine. So let's try writing a test. So we can say we need to make this a public method. Invoke 1, 2, 3. let's see what we have in the editor. OK, so we have this cacheable function. You can see the tests are all listed on the left-hand side. Let's see. OK, so this is passing. How do we know that it's working? Well, first, let's print the output. That would be, and actually, yeah, we're expecting it's going to double the number. So let's say assert that this is equal to 246. So the function is working. How do we know that it's being cached? Well, we can, maybe we'll just start by logging something. So got existing value from cache. Otherwise, maybe we'll just log not cached. And then we're going to call this function twice with the same input. So let's run this test. And we see here it said not cached. And then the second time is getting 246 from the cache. And the other cool thing is, yeah, if we go into Docker, or I'm actually using this third-party tool called OrbStack, you can actually see we're running Redis in a Docker container on our local machine. And then when we deploy it to a cloud provider, it will be using something like Elasticache or one of those other cloud providers, et cetera. So hopefully this is a little flavor of what it's like developing and building in Wing. We're building out a library ecosystem. So yeah, to kind of recap, it's an open source programming language. It's all on GitHub. The language, the compiler, the standard library. We're aiming for this kind of instant local simulation experience that really improves your iteration times. It's really designed around embracing the diversity of the cloud. If you really want, say you're just interested in the infrastructure, you can kind of treat it like a superset of Terraform. One thing I didn't show, but Terraform has all of these providers already available, for major clouds. Most of those you can already use in Wing through these automatically generated bindings. It's still pre-release, so we're kind of on the path to 1.0. We're trying to stabilize things, but we'd really love to get your feedback. Like to see people try it, get your feedback, what you like, what you not like. We have an online playground you can try. So if you don't even want to install it on your own system, it's very easy to try things out. And yeah, that's Wing in a nutshell.